So welcome to all. Myself Dr. Santhosh Singh, working as an Associate Professor in Department of Physics, Institute of Aeronautical Engineering. Today I am going to discuss about diode laser. In my previous video lecture, I already discussed about the characteristics of laser. Okay, so today I will try to focus on mainly diode laser, how the diode laser will work. So let's start the topic. So the other names of diode laser is injection laser diode, semiconductor laser, or diode laser, or laser diode. Means the diode laser will be known by some other name like injection laser diode, short form is ILD, semiconductor lasers, and laser diodes. Okay. So a laser diode or diode laser is a semiconductor device similar to a light emitting diode, in which a diode pumped directly with the electrical current can create a lasing action or condition at the diode junction. Means it is a kind of very similar to photodiode. Photodiode means a kind of diode which which will, which will be able to generate the light. Okay. So diode is nothing but PN junction diode. P-type and N-type crystals, semiconductor crystal will join together and they will create a formation of junction diode. And if these semiconductor crystal have a sufficient or one particular range of band gap, then it will able to emit the light. Then this diode is known as photodiode. Okay. So your diode laser or laser diode is a very similar to photodiode because it will also generate the light. But what is the difference? Whatever the light generated by photodiode will not follow the characteristics of laser. Okay, means they will not show some highly directional phenomena. They will not show some coherency. They will not show the intense, high intensity. Means number of photon will be available per unit area, per unit volume will be not too much high. But obviously it will generate a light. But for getting the laser light, your light will try to propagate in a unidirectional. It will be high intense light. It should be coherent in nature. Okay. So means all the laser light characteristics, if that light will follow, then you can say this is a kind of diode laser. But in photodiode, the light, whatever the light will emit by this junction region, let's suppose this is H nu photon. So it will try to travel in all the possible directions. So if such light which are able to move in all the available direction, that will be not the characteristics of laser. But anyhow, if you want to get the laser right, and anyhow if you are getting the light which will follow the characteristics of laser, means what? The same thing will be able to generate the laser light also. Okay. So that's why it is written. It is very similar to photodiode. But what is the difference? Whatever the light will generate by this device will follow the laser characteristics. What are the laser characteristics? It should be monochromatic in nature, highly directional, high intense, and it should be coherent. So generation of light will be initiated like a photodiode, but that light will follow such characteristics. Then you can say it is the laser light. Okay, so that's why it is written here. So a laser diode is a semiconductor device similar to light emitting diode or photodiode, light emitting diode (LED), in which a diode pumped directly with electrical current can create a lasing condition at the diode junction. Sorry, not photodiode, LED, light emitting diode. So in light emitting diode, what happened? Let's suppose this is your energy axis. So diode laser is a semiconductor device similar to a light emitting diode. Light emitting diode means LED. So what is light emitting diode? Light emitting diode is a kind of device which will convert the electricity into form of light. Okay. So and it will be built by semiconducting material. So what happen in LED? In semiconductor there are valence band and conduction band. Okay. So normally the electrons will reside in valence band, and if anyhow it will get any kind of energy, it will reach to conduction band. It will stay here up to 10 to the power minus 8 seconds, and after that time period they will again return back to their valence band. While returning time they will emit the energy, they will emit the radiation, and if this radiation will fall in the visible region of spectrum, electromagnetic spectrum, you will see that radiation in the form of light. Okay, so this band gap EG is very important for constructing the LED or any light emitting devices, any semiconducting light emitting devices. This energy band gap is very important. Why? Because this energy value, the radiation will be emitted. Whatever the energy value of, whatever the energy difference of these energy level. Let's suppose if this energy difference Eg is x electron volt, so whatever the radiation will emit in the form of light or any electromagnetic radiation, that radiation will have a same amount of energy. Let's suppose that radiation will come in the form of photon. So h nu will be equal to x electron volt or Eg. Always. This is the well-known fact. And if this Eg, this band gap value will be in the visible part, lie in the visible range of a spectrum, that is from nearly 1.7 electron volt to 3.2 electron volt. What happened? You will be able to see this radiation in the form of light. Okay. So this is the main concept. Okay. So any light emitting diode, whatever the principle behind the light emitting diode, on the same principle this laser diode will also work. But what is the main difference? Whatever the light generated by this light emitting diode will not follow the characteristics of laser. What are the characteristics of laser? The characteristics of lasers are monochromaticity, second, highly directional, coherence in nature, and monochromaticity, highly directional, coherence in nature, and high intensity. Intensity of laser beam means available number of photon per unit volume in laser light beam will be too high comparison to normal light. So whatever the light will produce by LED will not follow these characteristics. That's why you can't say this is the laser. But if anyhow you maintain such conditions so that whatever the light will emitted by LED will follow all these four characteristics. Means if that light will be monochromatic in nature, it will propagate in a unidirectional, means highly directional. That light will be in phase, means coherence in nature. And if it will be contain high number of photon, large number of photon per unit volume, then you can say that that is the laser, not light emitting diode. So that's why it is written. The generation of light will be very, very similar to the principle of generation of light of LED. How the light will generate from the LED, it is very, very similar to the principle to the laser also. Meaning the same principle will be applicable here. Okay. So that is some introduction about laser. If you know the LED, how the LED will work, what are the principle behind the LED, you can easily understand the laser diode. Okay. So now, what is written here? In laser, I already told there are some pumping mechanism. Pumping mechanism means generally the electron will reside in their ground states, and by getting some energy from any external source, they will jump to their excited states. Okay. So, from which source or from which mechanism these electrons are getting the energy? That mechanism, the way to achieve or the way to acquire these energy is known as pumping mechanism. So here in the case of the laser diode or diode laser or diode laser, both are same. Don't be confused. Another name is injection laser diode. So both are same thing. Injection laser diode, semiconductor laser, or diode laser, all are same. Okay. So in diode laser, the pumping mechanism is electrical. Means by some using some external battery source, kind of battery source or potential source, you will supply the energy to these ground electrons so that they can reach to their excited states. So here the pumping mechanism is electrical. Okay, means you are using the electrical energy source for supply the energy to electrons which are reside in their ground state. That's why it is written. Driven by voltage, the doped PN transition allow, means these P and N levels in diode, and these P and N levels are what? It is doped level. How you will achieve the P type and N type semiconductor? You have to dope something to get P type and to get N type semiconductor crystal. So driven by voltage, the PN doped PN transition allow the recombination of electron with hole. Means if you bias these combination, let's suppose you are doing forward biasing. So with the help of these biasing, whatever the available free carriers here, free carrier means in the P side there will be holes and in N side there will be electrons. So they will recombine. Recombining is nothing but you can understand it clearly by band structure. Band structure, valence band, conduction band. Now electrons are normally in valence band. If they will get a sufficient amount of energy, they will reach to conduction band, and they now electrons are here, and they will left behind their counterparts that is known as holes. Here the electrons. Now with the help of this biasing, this thing will happen, and after 10 to the power minus 8 second, what happened? They will again return to their ground state. Means they will recombine with their counterparts. Electron and holes recombination. And while this process, they will release some sort of energy. And if this energy will be falls under visible part of the spectrum, you will get the visible light. So that the same thing is written. Driven by the voltage, the doped p-n transition allow for recombination of electron with hole. Due to the drop of the electron from higher energy level to lower one to their ground state, the radiation in the form of emitted photon will be generated. This is the spontaneous emission. One thing, during this recombination process, whatever the photon or whatever the light will generated, that light will be comes by the spontaneous emission process. Spontaneous emission process. What is spontaneous emission? What is stimulated emission? What is absorption? I already discussed in my previous video lecture. You can see that. Okay. Why I am mentioning this? Because we are dealing with diode laser or laser diode. So, okay. So for lasing action or for getting the laser, this spontaneous emission photon is not able to produce any kind of laser light because they are spontaneously emitted. Means they will no tendency to follow the laser characteristics. For getting the laser light, whatever the photon will generated by stimulated emission, that photon only follow the characteristics of laser. Okay. But why we are discussing this spontaneous emission? Because this spontaneous emitted photon will trigger the stimulated emission process. Okay. Means this spontaneous emitted photon may be hit any another electrons which are already available in their excited state by this voltage driven process. Now before 10 to the power minus 8 second, if this emitted photon will hit this available excited state electron, this electron will not wait here up to 10 to the power minus 8 second. They will jump or they will return to their ground state, and while returning time, they will again emit one photon of similar frequency. Okay. Now two photon you will get. One photon initially you have by spontaneous emission process. Now you are getting one more photon, and this new photon will follow all the feature of this parent photon. Means in what direction this photon will go, this photon will also go in same direction. Whatever the frequency of this photon, this photon will have same frequency. Means unidirectional and monochromaticity feature maintained. Now, if this phenomena happen rapidly, again and again, the number of photon will increase rapidly. Means the intensity is now increased, and they will be also in phase. Means coherency is also maintained. Now, what you are getting? You are getting the laser light. Okay. So this is the overall basics of diode laser. Okay. So here it is again written clearly. It is a specifically fabricated PN junction diode. Specifically fabricated means whatever the width, what the width should be for P region and what width should be for N region, you have to focus on that thing also, because I already discussed about the what are the effect of dimension of your crystal. Okay, once I was discussing the quantum well structure. So what I told, what is quantum well? If you confine the one region, one direction of any semiconductor crystal or any crystal, the entire property of crystal will change due to confinement effect. Okay, so for getting or for manipulating or for band gap tuning, you can choose your width of your available crystal. Okay, and you can also dope these available p type and n type semiconductor up to certain doping concentration. Okay, so that you are able to achieve the phenomena of population inversion. What is population inversion? I already discussed. Okay, so that's why it is written. It is specifically fabricated PN junction diode. This diode emits laser light when it is forward bias. So it is a very similar kind. It will work on a very similar manner like a LED. So you know that the LED will always work on forward bias. So that's why this diode laser will be also biased in forward bias. Okay. Now what is the principle? So I already discussed. Let's see again. When a PN junction diode is a forward bias, the electron from N region and holes from the P region cross the junction and recombine with each other. P region, N region, now forward biasing. Now holes from P region and electrons from N region. Okay, recombining due to this biasing effect, and with this recombination process, some sort of energy will release, and that energy will initiate the lasing action, stimulated emission process. So that is written here. So when PN junction diode is a forward bias, the electron from N region, electron and holes from P region cross the junction. This is your junction, and recombine with each other. During the recombination process, the light radiation photon is released from a certain specified direct band semiconductor like gallium arsenide. This light radiation is known as recombination radiation. This is not a laser light. Laser light will come now when this recombination radiation will trigger the stimulated emission process. Now, photon emitted during the recombination, see, stimulate the other electron and holes to recombine. As a result, stimulated emission take place, which produce a laser. Okay, So clearly written here. So laser diode form a subset of larger classification of semiconductor PN junction diode. Forward electrical bias across the laser diode cause the two species of charge carrier, holes and electron, to be injected from opposite side of PN junction into depletion region. So one depletion region will be formed near to junction, and this depletion region have a great importance. Why? Because the light will not emitted from whole device. It will be emitted from nearly to junction region, means from depletion region. Okay, I will discuss in some other video what will be the role of depletion region. I already discussed the quasi Fermi level. The role of quasi Fermi level, this quasi Fermi level only available in the depletion region. Okay, available in the what? Depletion region means what? The depletion region is only important for optoelectronic device characteristics, not whole device. Obviously, the whole device have some role, but whatever the main phenomena will happen, due to that you are getting some light or any optoelectronics phenomena, that is only happen in the depletion region. Okay, so that depletion region have a very important. Don't think this depletion region have now don't enough number of charge carriers, so it is don't have much importance. It is the main most important portion of your optoelectronic devices. Okay, so that is written here. Now holes are injected from p doped into n doped semiconductor and electron vice versa, means from n doped to into p doped. So what happened? A depletion region divide any charge carriers form as a result of the difference of electrical potential between N and P type semiconductor wherever they are physical contacts due to use of charge injection in powering the most diode laser. This class of laser is sometimes termed injection laser or injection laser diode. Means there are some potential difference also created due to the charge difference in each side. Each side means P type and N type, and due to that difference, they are continuously recombined. Means also it will be trigger the electron excitation, so that the holes will create, and then again they will go for recombination. Okay, so as a diode laser or semiconductor device, they may also be classified as a semiconductor laser. Either designation distinguish diode laser from solid state laser. Okay, so this is the some diagram about your diode laser. So see here, this is nothing but a simple PN junction diode which are forward bias. Now electron and holes are try to recombine. Electron try to reach from N region to P region, and holes will try to move from P region to N region, so that they will recombine. During this recombination process, they will emit the photon, and this emitted photon is known as radiated photon. This radiated photon will trigger the stimulated emission process. And due to this stimulated emission process, you will get the laser light. Okay. Here some construction of your laser diode is given. See here, one P region, P-type semiconductor thin sheet, and downside of this P, one N region. So see, this is your N region, and this N region have some larger width comparison to this P region. Now this is your junction. This line is indicating PN junction region. Now this is one contact, ohmic contact, so that you can bias this. So this is, let's suppose this is one P-type semiconductor rectangular sheet placed over N-type semiconductor rectangular sheet. This N-type semiconductor rectangular sheet has some larger length and larger width comparison to P-type semiconductor layer. Okay, means this N-type semiconductor layer has some larger width, so that the proportionality of charge carrier will be different. Here in N region, the available number of electron, the free charge carrier density will be more comparison to P region. But anyhow, due to biasing, this is the one ohmic contact in both sides, upside and outside. Both the ohmic contact will be there, so that you can bias these PN junction, available PN junction, and so that the electron and holes will be recombined with each other, and you will get the laser light. And why this you are keeping this N region, N semiconducting layer, N type semiconducting layer in larger width, and also having higher doping concentration. Why? Because if you are keeping the larger width and higher doping concentration, the available number of electrons will be large. So that you are able to maintain one condition that is known as population inversion. Okay, that's why you are keeping this N-type layer width is more comparison to P-type layer width. Okay, so this is a very simple diagram of laser diode, where the two layers of semiconductor, one is P-type and another is N-type, are placed on over each other. Means if you are keeping the N-type layer downside, you have to place P-type layer over that N-type layer. What you have to take care, the N-type layer widths will be more high comparison to P-type layer. N-type region should be broader, okay, and make some ohmic contact so that you can bias these two semiconducting layer, and you will definitely get, if you are able to construct such type of structure, means where your N type of layer have a larger width comparison to P type of layer. So this is nothing but a kind of diode. But what happened here? Your N type layer have a larger width and larger carrier concentration comparison to P region. Now you are making you bias these available PN junction diode. Definitely, if these semiconductor have the band gap in the visible region, you will definitely able to get the laser light. Okay. So the photon emission is stimulated in a very thin layer of PN junction. This is the junction. From here, depletion region. From depletion region will be created near the junction, and from this depletion region, the laser light will be emitted. Okay. The electrical voltage is applied to the crystal through the electrode. This is your electrode, ohmic contact. fixed on the upper surface and down surface also. The end face of junction diode are well polished and parallel to each other, and they act as an optical resonators, because the whatever the stimulated by the stimulated emission, whatever the photon will generate it, if you keep these junction well polished, they will reflect it back inside the crystal, and while reflecting time, they will again go for stimulated emission process, and they will increase their number. So the intensity will increase. So this is same thing, carrier recombination process. So see here, electron will recombine with hole in depletion region, and while this recombination, the light will generate it. So this region is only important, this depletion region, not all the device. Okay, so electron initially in their ground state now reach to their higher energy state. It will stay there up to some time period, then again fall back to their ground state, so that they will recombine with their counterpart. And while this recombination, they will emit the radiation in the form of light. That is the whole phenomenon. Okay. So when the PN junction is forward biased with large applied voltage, the electron and holes are injected into junction region in considerable concentration. The region around the junction contains a large amount of electron in the conduction band and the large amount of holes in the valence band. All these things I already told. If the population density is high, a condition of population inversion will achieve. The electron and holes recombine with each other, and this recombination produces a radiation in the form of light. When the forward bias voltage is increased, more and more light photons are emitted, and that light produced instantly become stronger. Okay, means the intensity will increase. These photons will trigger a chain of stimulated recombination, resulting in the release of photons in phase, means they will maintain the coherency. The photons moving at the plane of the junction travel back and forth by reflection between two sides. That's why you maintain polish these surfaces, end surfaces, so that electron will reflect back and forth, so that they will again trigger the stimulated emission process. Okay, so the photon moving at the plane of the junction travel back and forth by reflection between two sides placed parallel and opposite to each other, and grow in strength. After gaining enough strength, it gives out a laser beam of wavelength 8400 angstrom. The wavelength of laser light is given by this formula. Eg is equal to h nu, where Eg is band gap. This band gap Eg is equal to h nu, and h nu is equal to c by lambda. So lambda is equal to hc by Eg. Okay, so this is the formula, hc upon Eg. Okay, so it is the solid state semiconductor laser. So this laser is characterized as a solid state laser. Here the active medium, laser have several components. So active medium, what is the active medium? Okay, so PN junction diode is an active medium made from a single crystal of gallium arsenide. Okay, what is the pumping mechanism here? So electrical pumping will be used. You will bias the available PN junction diode. Okay, the power output. So the power output is in the form of laser, and the power of that laser will be nearly equal to the 1 milliwatt. Okay, nature of output, so it will be either in the form of continuous wave or pulse wave. Okay. Wavelength of output, so it will be nearly 8400 angstrom. So you can say in between 8300 angstrom to 85, in between 8300 angstrom to 8500 angstrom. So what are the advantages? So it is very small in dimension. The arrangement is simple and compact, highly efficient. The laser output can be easily increased by controlling the junction current or biasing voltage. It is operated with lesser power means less power is required for getting the laser light in comparison to carbon dioxide laser. It requires a very little auxiliary equipment, so very cost effective. Very simple kind of things is needed to build the laser diode. It can have a continuous wave output or pulse output. Okay, and what are the disadvantages? It is difficult to control the mode pattern and mode structure of laser. The output is usually from 5 degree to 15 degree, means some diversion will achieve. Theta is around 5 degree to 15 degree. What is this? Generally, the laser characteristics is it should be travels in a unique direction. So whatever, obviously, no laser, whatever the laser, obviously it will be deviate from its linear path, more or less. But in a highly efficient laser, it will be deviate very less. Okay, but this diode laser deviation is nearly equal to 5 to 15 degree from their center path. The purity and monochromaticity are lower than the other types of laser. Lower than other types of laser. Threshold current density is very large. Okay, 400 ampere per millimeter square. Okay, it has poor coherence and poor stability. Whatever the light you will get, it will not generally well in phase. So coherency is little bit debatable in laser diode case. So application, it will be useful in medical application. It can also use for writing the CD or DVD, and also in communication system. Okay, so it is very useful. Okay, so in medical application, in communication system, and in IT field, writing CD, DVD, and in laser printer, it will be useful. So that's all for today. Thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.